My name is Jason Straight, and you guys are here for Leveraging Cloud for the Modern SQL Developer. Just a little background on myself. I've been working with SQL Server for about 17-ish years, been doing things on it for a while, and been playing around with Azure here for a couple of years. It's actually my primary development environment, just because of the flexibility of what I can put up into the cloud and how I can build and destroy machines at a whim. We're not going to talk too much about actual virtual machines though today. We're going to talk more about SQL Database, which I do actually have a few of those that I use on a daily and weekly basis. Towards the end here, I will answer any questions that we generate throughout the session today. But if we don't have time, or if you do have another question that comes up to after the fact, please feel free to email me, and I'll do my best to answer that as soon as possible. I don't have any specific resources, though, at the end I can put up, but I can direct you to Pragmaticworks' cloud solutions offerings if you want to find out more about what we can offer as Pragmaticworks. That's enough, though, of not talking about our solution today. Let's talk about the old days of developing SQL Server databases. In the old days, back in the SQL 7 days and the SQL 2000 days, it was like a great time for developing databases, because what we would basically do, we could sit on the porch, we could drink some lemonade, and we could just make it happen. And the reason why we would make it happen is that we weren't really doing it the right way. We were doing it really poorly. What we were generally doing is going out to production whenever we wanted to make a change and just making that change. And the reason that we did that is that we just didn't have the right types of environments in place so that we could do this stuff cleanly and be able to get out of there alive without having too much overhead in putting this all together. And the tool set that we had there back with Query Analyzer and the Enterprise Manager, those just didn't help us with a development process. They're great for administrating the tool, but when we had to create and go out and build that great new car for our environment, we didn't have a great tool set for doing that. And as time's gone on, we've had to build bigger and better and faster cars, and that's had us ask about the idea of, what is our tool set and how exactly are we going to push this? Is my obligatory cloud picture. How are we going to push this all together and develop out the solutions that we need? And that's what we're kind of here to talk about today. We're going to talk about the modern SQL developer, and we're going to talk about SQL Server data tools, and then we're going to also talk about SQL databases. So as we're going through all of this, I want to talk about why we would even consider SQL database. What is it, and why would we want to do that? Then we're going to talk about designing databases, what you can do with data tools to build up a database and put things together. Talk around and doing some demonstrations on deploying databases and your options there, and to show you that really that horrible time that we had in the past of deploying databases and being kind of forced into making changes to the production database or generating change scripts that just didn't work is kind of behind us. Then we'll talk a little bit about cloud performance and some of the new options that you can use for scalability with your SQL databases, and then your scaling options with SQL database and how your abilities to scale up and scale out, and how that's really the way that data platforms need to be moving. It's really the way that gives us assurances that SQL Server and our applications most specifically are going to perform how we want them to perform. Now, with SQL databases, why would we want to do a SQL database? Well, before we get into that, let's first talk about what a modern data platform looks like. In our modern data platform, and this is what we've been using for years and years and years, we've got our server that sits maybe in another data center, or maybe it sits in our own data center. And from there, we're pushing data in through some devices, through other databases, through our applications, through data files. All this data is coming in, and it's then going back out to other maybe mobile applications, to your Excel users. Maybe it's some websites or on-premise applications, reports, or again, maybe other databases. But we have here in our modern platform kind of a single point of failure. That single point of, we've got one option. Sure, we can do anything from deploying SQL Server in Standard Edition up to Enterprise Edition. We can go and get 2 procs, or we can go and get 160 procs. We have a lot of flexibility there, but we're still stuck with having to do everything for that server, having to do all the maintenance, having to rely on other groups for putting together how the application will, well, not the application, but the database will be able to come together, and we don't have many other options in that landscape besides how we architect our specific databases and what kind of hardware we put it on. And that opens up an opportunity where we can look at something a little bit different, where we can go out and, instead of having to take on the entire task of putting data into a SQL database or SQL Server database, we can bring in a cloud-based solution, something where we don't have to do all of the work for ourselves. And when I've talked to customers, this has really been a bottleneck, this idea of, well, before I can even start on this project, I have to go and get a server requisitioned, or I have to make sure that there's room on my development server, or I have to make sure that I have the entire budget to pay for the entire thing today and get all of the approvals before I can even move forward. And that's great for, that's great for the old world, but the new world is we don't have the kind of budgets and the buckets of cash laying around that we kind of had back in the 90s, when anybody could get anything, and having profits was, well, that was nice, but it wasn't really necessary. And things changed, and things came back into alignment, and typically we don't want to pay for everything before we get the services. Usually, or at least the way that I like to pay for things, is I like to pay for them as I know that I'm getting what I want. And I don't want to overpay for things. When I go and rent my cars, I don't pay for that full tank of gas if I'm not going to use that full tank of gas. And so cloud gives us some of that flexibility. And with SQL Database, which is Microsoft's platform as a service relational database in the cloud, you have that ability to build your database on a consumption-based model. And so you can build it out and have the things out there that you want, and it's basically SQL Server Database Online. It's a fully relational SQL Server database that you can get to in the cloud. And it's got built-in features that allow you to maintain some of the core requirements that you have with a database that sometimes people don't go out and get. The nice thing about SQL Database in the cloud is once you've done and you've developed a cloud database leveraging SQL Database, for the most part, except for introducing your own new features, you've kind of hit your last migration. There are some things that could happen. For instance, if you need to expand and that current data center can't handle additional expansions, that is one issue that you might run into, but that's fairly few and far between. Generally with SQL Database, once you get it deployed, you're ready to go. And then as new features are introduced, they're just there and available for you. And so it's this last migration and this ability to just work on the features and deliver only value from your application that really brings out the value of SQL Database. With SQL Database, there's a number of benefits that come in alongside what we've talked about. This is mainly that you can build out. You have built-in high availability. There's 2 replicas of every database that gets deployed. There's automatic disaster recovery that you can put in with making copies and shipping off your database to other data centers. There is performance governance, and some people usually look at performance governance and they're like, I don't want SQL Server. I don't want to go on a platform where my SPIDs get killed from time to time because I've got a runaway query. Well, what's the alternative on your own environment? If you have a runaway query on your own environment, now other people, maybe not you, but maybe other people now are suffering under your workload. So they've got performance governance in there to not just to constrain you, but to also protect you from other people's databases that are out there that are running. It's minimal maintenance because this is something that's built up, it's set up, It's ready to go. You're not having to go out there and making sure that you do check DBC, check DB, well, DBCC, check DB. You don't have to go out there and make sure that you're doing your checks with the logs. You're not out there monitoring CPU too much. And a lot of the things that we have to do locally with an on-premise SQL database is kind of gone. This isn't something that's going to kill the DBA, but it is something that changes the DBA and how you get to work with the DBA on what's going on. And then you have the ability to scale out. And as I'll talk about later on when we talk about performance, there's a number of ways that you can scale up and scale out your SQL database so that you're not just constrained by the one database or the one set of resources that you have available. You can actually scale those up and down as you need. So when it comes to designing databases, and that's kind of the core of what we want to talk about here today, when it comes to designing databases in SQL Azure, your main tool is going to be SQL Server Data Tools. SQL Server Data Tools was released, I think we're sitting at about 5-6 years ago now. I'm thinking 5-6 years ago now. Maybe it's 4 or 5 years ago now. But SQL Server Data Tools was really that I mean, it kind of felt like it was like a version 1 of a real developer tool. Before SQL Server Data Tools came out, you had Query Analyzer, which was back in the 7.0 and 2000 days, which was just painful to do development work in. You had Enterprise Manager, which was not a development tool. We had to use it as a development tool, but it was painful to use. We then had Management Studio, which we could do some development work. We could build things up into projects. It didn't work very good for actually doing development work because you didn't have a really good collection of how the database tables and views and stored procedures all went together. You couldn't do any real good build analysis. It was mainly just a collection of scripts which relied on you to put the scripts out there in order to get the kind of layout that you wanted for your project. It works really good if you're just doing scripts that you want to have for a demo. Doesn't work really good if you're trying to maintain a database for deployments. Then we also had within Visual Studio, we had some database tools, we had some database comparison tools, but those pretty much just, well, they sucked. They just didn't work the way that they really should have. I know that I spent, prior to SQL Server Data Tools, on the previous tools, hours and hours trying to get a good database comparison to work. With SQL Server Data Tools, I can just use SQL Server Data Tools to do comparisons between databases, and it really does work. Now, with SQL Server Data Tools, it's really our full-fledged development environment, with the idea that database developers are going to use this for doing development work. It incorporates a lot of the current developer needs, things that you need to do when you're developing databases. You can use database projects that work, source code control, so you can easily tie this into TFS. There's not a lot of extra effort to doing that. It's the same story as putting a .NET application up into TFS. And you can use not just TFS, but you can use any other tool that merges into Visual Studio. You can do the offline code management with your local DB. We're not going to talk about that piece too much today, but it basically is a way to instantiate your database off of the server so that you can do your development work there. And then it offers good schema and data comparison, so you can find out, what's there, what's missing, and you can get your scripts put together. The other thing I don't have in here is that it handles all of your build, testing, and deployment needs. So deployment, when it came to SQL Server, well, back when you're just using plain Visual Studio, not with data tools, deployments were kind of tricky. And in the deployment section, I'll talk about why those were kind of tricky and how this is the new paradigm is much better for that. Now, the development is, in this case, I mentioned local DB, and development is independent of production. So you can work on this and you don't have to be out on production. You don't actually have to be on a server to get this all working. And when it comes to it in using SQL Server data tools, you can just build out a table, and it's a similar paradigm to just using regular Management Studio for building out tables. You have a lot of the same functionality and tools. They're laid out a little bit differently, but it's still the same concepts. Now, when you're building out tables and you're doing any sort of design, there are some things that you have to pay attention to. There are some differences between SQL database and on-premise SQL Server databases. Some of the big ones is that databases in SQL Azure, SQL database, you can't have heaps anymore. You always have to have primary keys. I wouldn't necessarily say that these are bad restrictions. I like these restrictions, but these are some things that if you're migrating a database up to SQL database, you'll have to pay attention to. And there are some language restrictions that are currently out there and object restrictions, such as CLR is not currently available. You can't do database mirroring, and you can't do always on within with a SQL database. But there's a lot that you still can do, and you can cover for many, and probably even most applications. They do have a place where they can fit in SQL Azure or SQL database. I say SQL Azure on occasion because I think over the last 3 years they've changed the name for the SQL database product. It used to be SQL Azure, then it was Windows Azure SQL Database, and now it's Microsoft Azure SQL Database. Those names change quite a bit, which is a bit unfortunate. But let's get into actually looking at a couple demos here. And so what we want to do here is I want to show you guys what it takes to really just develop out and build a database in SQL Server Data Tools, and then deploy that out to the Azure environment. So when you're creating any data tools project and the things that you need to do for doing these with SQL Azure in mind, you'll just go into doing a new project. I'm going to throw it into the same folder that I'm using for all of this. And what I will do from here is I'll just call this Modern DB. And at this point, I've got a name for the project, and I've got it set up, and we're ready to go. Now, if I go and take a look at the solution after it gets prepped here, we're going to find in the solution that there's not too much here. It's all kind of baked in already, and you've just got some properties and references. From here, though, you can start building out your database for going up into the cloud. There is one thing that I always change before I start building out my cloud database or my SQL database, and that is to change it so that it is going to be a Microsoft Azure SQL database. You want to make sure that you include this change as early as possible, mainly because you don't want to bring in any components that may conflict with pushing out to a SQL database. The list isn't incredibly long, but there are a number of things that don't work between the two. And so now that I got those done, I can change the default schema if I want to, but in this case, let's just leave that as it is, and there we go. Now in this case, you can easily get to the point where it is going to be development, just like if you're connected to the object browser in SQL Server. And that's the way that I prefer to use this. I don't tend to go through and just add in objects, which you can if you want to. You can start adding in different objects, and in this case, let me just click on, I'll just click on table, or table value function, because that's going to bring up the full list. So I could go in and I could start adding in, where is it, under security, I could start adding in some schemas and all of that. There's schema. I could start adding in all of these pieces, but I actually don't want to do that in this way. The way that I prefer to work with this is I switch this over to an object browser look. And when you switch it over to the object browser look, it does start to look exactly like if you were still in Management Studio. I'm a DBA at heart, and so I like to do my development in this way. This way it keeps all my objects logically separated for me. And so what I can do here is let's go and create a new schema, and I'll create a schema here. It'll give me that option. It's going to automatically go down to the schema name, and I'm just going to create a schema called sales. And once I get that created, now if I expand that out and let me just close that. I thought I disabled that. So if I take a look at here, and sales is right there, so I've got that schema. And if you think about the other schemas that come with SQL Server databases by default, all of those are already in there. It's basically building up a database as you put things in there. And so then we can add things in here like tables, and we'll do that real quick. And let's create a table. We'll just call this sales order header. So we'll add in a new sales order header table. And now that we got that, we can add in some columns here. So we'll skip it sales ID. And let's see here. Customer ID. We won't add in too many pieces here. Create date. And unit price. So all the common data types that you're familiar with are all here. The only thing that you can't use is anything CLR based right now. And I say right now, and that's an important thing to point out, is I mentioned it earlier, SQL database is changing all the time, so you do want to make sure that you pay attention to the things that are coming out. And things change sometimes just overnight. And when we get to the end, I'm going to show you something, or talk through something that actually changed just yesterday with SQL database, and it's a huge and important change for all this. So let me just save this. And if anyone's paying attention, you probably noticed that I didn't add this into the sales schema. It's a DBO object, so you can actually change this within here if you want to, using refactoring that comes into the refactoring options that come in. Let me just bring that up again and do a quick zoom in. So you can do renames, you can do moving to schemas and fully qualified names for refactoring, so you can do some of that refactoring that we sometimes have to do. And if you've ever had to do that on a database without using data tools, it's a pain. So in this case, just change that to the sales schema and click OK. So it's going to go through here, it's going to make the changes here. We can make that, we can apply that. And now if I just refresh this, we're going to see here that it's changed the schema for this. And if we open up the object, it's going to cooperate with me there on what that is. We see that we've got the sales in there. And then the other thing that we can do is we can view the designer, and we can get back to that screen where we're doing the designs through this screen. So it gives you really that feel for Management Studio, but it gives you that ability to then build out databases. And this is just like you could do on-premise. But there's a couple other things that we'll talk about in the deployment that helps you get it out to the cloud. Now, this isn't the only use case that you're going to have for your databases. You may have databases that you want to move to the cloud. It is a common scenario where people will move databases from on-premise to up in the cloud. And so let me get Visual Studio here started again. And I'm going to create a new project here. Because one of the things that you're going to probably have that's most common when you're working on this for the first few times is you may have a database that you've already built out that you now want to move up to the cloud. And moving things up to the cloud that you've already started development work on is actually a fairly simple process, even if you don't have a project built for it already. And you do that by importing. Now, I know that you could do this previously with the other tools that were available, but it wasn't always the easiest process to do that. And so when you do your importing, you can import it from a DAC pack, which we'll talk a little bit about later on. You can import it from a database or from just a collection of SQL scripts. Well, in this case, what we want to do is let's import it from a database. And so I'm going to choose to make a new connection. And I really shouldn't have hit that down arrow. I always hate it when I hit that down arrow. Really wish there's an option to just cancel that. So I'll let that time out for 30 seconds. And then I'll actually type in my SQL Server name. Come on, timeout. While this is timing out, I just want to remind you, if you have questions, please put them into the Q&A. I will get to as many as I can at the end. Most likely we won't be able to get to all of them, and the ones that we don't get a chance to get to, I will answer through a blog post, which I'll do as a follow-up, hopefully this afternoon. So I'm going to connect to my Azure version of AdventureWorks. Let me just pull everything in, import permissions and database settings. I'm just going to leave those off, but you can import those if you want. Once you get that started, it's going to pull together and it's going to bring down your it's going to bring down your database into Visual Studio and into your SQL Server database project. Once that's all done, now you have that entire project that's out there, and then you can start doing your development work, and that leads us into the next piece, because the next piece is how do you take that package or that solution and push that up to the cloud? How do you get that migration to work? And that's where we come to deploying databases. So with deploying databases, it gives you that ability to move, and this you can do all this within data tools and with the pieces that are out there, is you can go from on-premise to cloud, you can go from cloud to on-premise. You have that full capability to move back and forth, bringing your data with you as you move things around. The nice thing about building databases and deploying them through data tools is you get to build your database before deployment. So you get to find out if there's schema issues before you push things out. When you are doing deployments, the comparison that's being made between your schema and what you're deploying is being done at the deployment point. And this is kind of a really big deal. And the reason why it's a big deal is that at the point in which you're deploying, you may not have the exact same schema. One would hope that you would, but you may not have the exact same schema that you had when you were putting together the scripts for deployment. Maybe there's a new index out there, maybe somebody made a change out there, maybe part of the deployment already got pushed out there because of some emergency release. So when you're going and doing the deployment, what data tools and the deployment pieces are going to do is actually do a comparison at deployment time. And this allows you to have more successful deployments. And then, of course, as I already pointed out, you can do the refactoring within a project. And so you get a lot of opportunities with the database deployment model to remove some of the things that used to be problems in the past. And what you're really able to do is get to a point where it's not the Wild West on deploying out in your environments anymore. You can do more continuous integration. You can build things out so that you can unit test, so you can bring in TFS or another source code control. And you're really able to push the database development level of SQL Server up to the point where the .NET and other code development has been for a really long time. And it's been unfortunate that it took SQL Server and databases themselves to get this far. But we're really in a point where we can start to work with those all as one complete project and one complete product. We don't have to make that differentiation between, well, let's deploy the database, then let's deploy the application. Oh, wait, and this time we have to deploy the application first, not the database. You can start to treat this all as one overall code base versus segregating it out just due to a lack of tooling. Now, when you are pushing things out, there are two methods for pushing pieces out to the cloud or any type of deployment. Deploying from data tools, you have DAC packs and you have backpacks. With a DAC pack, it's basically a database schema compare, where you're just going to take the schema that's in the DAC pack and push that out to the deployment server. There's no data included with it. With a backpack is it's all the DAC pack pieces. So it's all the database, it's all the schema, but it does a replacement of the database as it's putting it out there because it brings the data with it. And so when you're able to move from the complete environment from one place to another. So if you're doing a full deployment and you want to make sure that you bring everything that you have in your pre-prod environment up to production, backpacks give you that ability. So let me show you what you're able to do with these backpacks and DAC packs. So let's go back to my project here. And so once you have your project and you have your pieces in there, and let me just show you show this build here. And so now we've got this together. Let me get this closed. Get that closed. That closed. All right, go back to, let's see, review in solution mode. Now that we've reviewed in solution mode, we get the ability that we can get this deployed. So let's build out this database first, make sure there's no errors with it. It's going to go through, and it found out that there are no errors because this one table has no problems. So now we've got that ready. The next thing that you're going to do is just publish the code. Now you can publish it directly from SQL Server Data Tools, or you can, and what it'll do is it'll create a DAC pack that it moves up. Or you can just specifically create a DAC pack and move that up. In this case, what we're going to do is we're just going to connect to my machine that's in the cloud, and let me just jump over to Management Studio so I can get there, because what I need to do is grab my machine name, because I don't always remember the full server name for my Windows machine, well, my SQL database, and then I'll grab my username, get that populated in there, and we'll pick a database that's out there. And right now there are no other databases in there. By default, it's going to be your project name for your database. You can change this if you want. I'm just going to leave it as it is. And at this point, it's going to get connected. And there's a lot of options that we have here with profiles and with script generation. But what I really just want to do in this case is just publish it out. So it's going to go through and it's going to deploy this database up to the cloud. And if we go in and we take a look here, let me just bring over my Windows Azure Portal. And if you're not familiar with the new portal, there has been some changes that are being incorporated into the Azure Portal, so that there's more that you can do, and it's a little bit easier to use. In this case, I just want to go to the actual Azure Portal, so I'll just click there. The Azure Portal itself with all the objects hasn't changed. Hopefully you're already familiar with this. If you're not, please go back and watch the session that I did this past week on Tuesday. But if we go and take a look at the SQL databases that are out there, let me just close that. We can see here that the modern DB has been created, it is out there, it is available. It did create it as a web version, and so that's out there and that's available. And so we've got that built up for us. So that's one of the ways to push things up. And if we go out to the database, let's just get connected to that. And I thought I turned off email, and apologize for that. So if we go out there and we take a look at the database that I have, and we know that there is a sales database. Get this to the right. There we go. We know that we've created that table. Let's just insert a row into that. We'll put in one, we'll put in one, we'll put in get date, and we'll put in unit price is $42. Everything should be 42, except for when I type 24. There we go, 42. There we go. So let's see here. Let's actually type out get date properly. We'll run that, take a look at that, and we've got our row. So I mean, it's like any other SQL database, SQL Server database, on-premise database. So it's all kind of the same there. And we have all of that. Now let's go back in here and actually let's not go to this one. Let us go back to this, and suppose we want to make a change, because that's one of the things that we talked about. So let's go back into the object browser with SQL databases and bring up this table. Let's actually bring it up in the designer. So we've got it here in the designer. You know, suppose that we want to add in a new column, quantity. This is going to be an int. And so you're able to do that full development process where you can add in new pieces and new components as you need them. And once you get that done, you can deploy things again. Why am I missing out on that? There we go. We can get things deployed again. And let me just edit that target database. Of course, I got to go back and get that database name again. Change the login. There we go. I think I've got Outlook killed there, so hopefully it shuts down. So I've got that. We want to go to the modern DB. Let's just do that. We will publish this change. It's going to start processing the change and push it up there. This change that it's using, it is leveraging the DAC pack, and so it can push that up there for you to use. Now, I talked about DAC packs already, and we could use a DAC pack to publish this AdventureWorks database, but maybe there's data that we've pulled in together with it, and maybe the data is out in our SQL Server database that we have right out here. And so suppose that we want to move this database up to the cloud. What you're able to do when you've got data that's in your database that's within your environment is you can do what is an export. And let me actually go back one more because I jumped through that pretty quickly. You can go back in under tasks, you have the ability to do an export. And this export is going to create a backpack from your database that you can push up to the cloud. Now I could do this in reverse. I could build the backpack within Azure and then bring that down locally, but for this scenario I'm just going to do it from Management Studio and push that up there. The one thing I want to point out is there's lots of ways to skin these fishes for getting this work to go through. And so what this is going to do is it's going to basically bring out schema and data into a logical backpack file format. And what this backpack file format is it's the schema for doing all the modifications, and then it's all the data from your database in BCP native format. Let's see here. And we can choose where we want to save it. We can save it to local disk, or we can save it up to a Windows Azure location. In this case, I'm just going to do it to a local disk, only to be quick about this. And let's just go to C, temp. We'll call this AdventureWorks Azure, get that saved out there. And so what it's going to go through now is bring everything down and drop that into a backpack file that we can use to deploy this database out to our SQL database. So while that's going, let's go back and check on that deployment that I did. So that deployment that I did where I made that one change, it's completed now. So it's successfully completed that publication. So now that it's successfully finished, let's go and look and see what has happened with SQL Server. And so if we just run our sales order query again, and we take a look, that column that we added out there, without us having to do anything special or adventurous or complicated to get this to synchronize up, that has pushed that up into the database. And so all of those capabilities are there and available and part of SQL Server data tools, but it empowers you to be able to push things up to the cloud at the same time. So it's all part and parcel of the same stuff. So let me see where this is at. Obviously something improper here happened. We've only got about 20 minutes left, so I'm not going to try and figure out why this is not working right now and why it worked last night. I'm just going to assume that I goofed something up quite drastically, but long story short is you could move that up there, and that's how I got actually my other databases that I have out there up here. Is I had this MPP database that's got a number of different tables in there regarding SQL Server MVPs, because I'm always curious who's currently not and who are the new MVPs each quarter, so I've got a little database that tracks that with all the Twitter accounts. I've got a presentations database that I created locally, which then I migrated up into SQL Azure because I wanted a database that I could get to anywhere that I was ever at, that I didn't have to worry about if something happened to my laptop or something happened to, let's not say that it's my laptop, but say something happened to my data center. I wanted to make sure that I always had that database. It was always online, and I had the highest availability for the lowest cost. And that's really what I get there. Or I've got this assessment master database. This assessment master, it works out with, it's one of the applications that we use for Pragmatic Works, but it gives me that ability that I have a database that's not isolated to my one data center or my one set of servers. I've got a data center that I've got a database that I just deployed, and it's just available and ready out in the cloud, and so any one of the consultants that need to access this database can at any time without having to worry about things like firewalls and all of those pieces. And the way that you empower that is by, with your SQL databases, opening up the IP addresses on what you want to allow. You can allow really large bands of IP addresses to connect. But generally, you're just going to allow the ones that you want to be able to connect, maybe just from your application or from your data center or from a subset of laptops. And if I were to have gone through and name all these, what you would have found is that all of these IP addresses for me actually map back to hotels that I've been in for the last couple of years. And so I've kept this really secure and only allowing myself and a few others to access these databases. And so just because you put it on the cloud doesn't mean that anyone can get to it. It just means that anyone you want to can get to it, because you have this ability to build up these firewall rules. So now that we've gone through deploying databases, I want to talk about cloud performance. Because cloud performance is one of those things, there's a few things that kind of get people when we're talking about moving things up to the cloud. One is security. And I don't necessarily have a slide on that here today, but security is one of those things that Microsoft does a lot of work to make sure that SQL databases and the virtual machine environment are compliant to regulations that companies need to deal with. One of the most recent ones that I saw that was completed was, I believe it was level 1 or level 2, I'm forgetting the level, PCI compliance. And so that if you want or need to host out your payment credit card, or your credit card information within SQL Azure, well, Microsoft Azure data centers, they do have the compliance in place for you to pass audits that are related to those situations. I don't have a slide for that, so let's just actually go on and talk about cloud performance. Now, cloud performance it's a little bit tricky. And it's not tricky because it's bad, it's tricky because you have to think about what you're really having happen. And the things that people typically complain about, which comes into the engine throttling, are things that you actually want SQL Server to do. This is actually something, if you spend some time thinking about it, this is something you would actually want your DBAs to do. What SQL Azure does is it's going to look at your partition size, it's going to look at your database size, how much you're using, what your data rights are, what your log rights are, what your number of workers are, and it's going to make some considerations based upon those to ensure that your database and those around you don't overrun on the resources that are available based upon the scaling size that you've selected for your database. And that's important because you want to make sure that, I mean, it helps you in a couple ways. It helps you with your own code because you have to make sure that your own code is going to perform well with your application. This may seem like an extra burden that you may not want to deal with, but it's a burden that you actually do want to deal with because you want to be building out applications that are going to work well within your environment. Too often I see people throw together code and it's like, well, it works. It may bring down the server, but I don't care. It just works. This makes us care about how our databases work because when the developer doesn't care how something works, it ends up turning out that the end user actually does care how well it works. And then they complain about it, and then it's left to DBAs to try to figure out how to make something that may not have been really well architected work well. In this case, everyone has to work together. Users have to define what their performance requirements are, and developers have to make sure things are working well, and the DBAs that are working on this have to make sure that they choose the right scale size. And we'll talk about scale size in just a moment, but that all makes us all work together. The other thing you have to think about is internet connectivity. The internet is not as connected as people like to think it is. You get disconnected quite a bit, and SQL Azure needs to be, when you're connecting into it, you need to take that consideration into mind when you're building up your connections. But when you're talking about these performance issues, you have to really think, is this really an Azure issue? Azure manages this issue, but it's not necessarily an issue that only involves Azure. And actually, pretty much every data platform has these issues. It's just the fact that SQL Azure has baked in processes to help manage around this and to make sure that everybody doesn't become a noisy neighbor, because the noisy neighbor affects everybody. And whether it's happening on-premise or in the cloud, it is a reality. The only really big difference when you're doing it in the cloud is that the noisy neighbor in the cloud, you probably don't know who that is. The noisy neighbor in your own data center is probably the guy on the other side of the cube, but that doesn't necessarily mean that just because you know who it is and what the application is doesn't mean you can actually do anything about it. And so, you know, there are some things that we can do, and there's things that we already do already by ignoring the problem or killing SPIDs on the server, complaining about it, waiting and waiting and waiting to see if things are going to get better, or if you're the person that's causing the problems, you just get yelled at. Noisy neighbor is something we already deal with. SQL Azure actually helps us move into a place where we don't get to ignore it anymore. Because if we do ignore it within our own applications, we'll have some SPIDs that are killed off. We don't get that chance to wait anymore, which then probably results in us getting yelled at, because it's going to have some SPIDs that are internally killed of ours because we're the noisy neighbor. And so those are the things that you need to pay attention to when you're doing SQL database development. And actually, you should be paying attention to this when you do any development. So if you've used SQL database in the last couple of years, so you've heard about it and seen presentations on it, these levels of performance levels for SQL Server are probably fairly familiar. You've got the basic, you've got the web, and you've got the premium level. And basically, between basic and web, you could get up to about 150 gigabytes, and then with premium, I think you could get up to 250 gigabytes. With premium, you had some slot reservations, and so you could get some guarantees on performance as far as memory and CPU were concerned. But with basic and web, it was mainly just be careful about the throttling that we talked about with noisy neighbors, and here's how much space you get, and some just really generic generic guidelines on performance. The downside to these is that there was a big gap between the performance that you get with basic and web and the performance you get with premium. And so just yesterday, there was a change that was announced with new service tiers. And so now there are some new service tiers, and these new service tiers are basic, standard, and premium. Not only do they have new names, they also come in color. And so they've got these new, no, actually they don't come in color. What they really do is they smooth out the differences between basic and premium, and they set up some guidelines. Now these aren't available as a released product yet. They are currently in preview mode. They are in preview mode with the intent that within 6 months that they are going to be the new way in which you select out your tiers. And actually the old tiers, basic, web, and just regular premium, are within the next, basic and web within the next 6 months, 6 to 12 months, are going to be removed as performance levels within SQL Database. Instead, you're going to have to choose between basic, standard, and premium. The nice thing about these is that you've gotten, with some of the guidance that comes with these now, some really hard, some real well-defined indications of what you can expect from a performance level. And so when you're looking at a basic database, instead of having a 1 gig limit, you now have a 2 gig limit. You can get up to 1 DTU per database. I'll talk about what that is in a minute. Up to 20 worker threads, up to 100 sessions that are currently connected, and you can get ASDB transaction throughput of 58. And then as you scale up and you scale out with your database, you get to choose between the other available levels. And so there's standard S1, standard S2, premium P1, P2, P3, and these all scale up so that as you need more resources, you can add these additional resources in. And as you no longer need these resources, you can scale them back down. Now with these, there is the DTU and the ASDB. What these two are is DTU is Database Throughput Unit. It's basically a way that internally they measure CPU memory reads and log activity to determine and set a specific benchmark, very similar to how they do TPC. But this isn't a TPC result. There isn't a web-based TPC, and so this is basically setting it from an internal measurement that Microsoft has put together themselves. There's not a lot of details on what this is, but with your own testing, you could get some really good ideas of, what do you need, and then with the metrics that they store on it, it lets you know when you're starting to reach your max DTU throughput, and you can scale up if you need to. The Azure SQL Database Benchmark, the ASDB, is a way of measuring the performance level by looking at transaction throughput. And so this gives you some really good metrics around what you can expect from your SQL database, and then when you can expect that you need to increase the amount of resources for your SQL database. Now, the next thing that they added in with all of this is some additional new business continuity features. And these new continuity features are really nice because what you're going to get is self-service restore. So depending upon which service level you select, you can get service levels that can give you point-in-time recovery. And so no longer do you have to build up processes for capturing all of your data changes. Built into the SQL database platform is going to be the ability to roll back to a specific point in time. Now, I don't have that exact point in time information figured out. I did read something a couple days ago that said it was down to a 5-minute cycle, but in that may have been the previous restore process. The current one, I haven't seen what because this information all came out just yesterday. The SQL service, the self-service restore basically for a basic database is, I believe, 24 hours, and I think for the premium it might be either 3 days or 3 weeks. I haven't. I mean, it's so new that I haven't had a chance to really dig into it myself too much. The other thing is active geo-replication, and so now instead of just having 2 replicas for your databases, or 2 readable secondaries, you can now have up to 4, and you can control where these are going to be based upon which data centers you want them to align to. And this really gives you that ability to very simply, through a subscription service, by just going through and clicking a couple buttons, deciding where do I want my databases to be. This is not, when you're working on a database in your own environment, it is not this easy. SQL Database really makes this stuff easy and accessible. Now, the last thing we're going to talk about, we've got about 7 minutes left to go, and I'm probably going to run just out of time for doing any live questions, but I will answer all the questions in an email as a follow-up. When it comes to scaling up databases, scaling up is something that you really need to have for your data warehouses. As I've moved more into solutions architecture, one of the biggest limitations I see on databases is the ability not to really be able to throw hardware at a problem to fix it. One really great example of a scalable database is Parallel Data Warehouse that Microsoft has for data warehousing. That's great for large, high-end, large and middle-tier data warehouses. But that doesn't help out on an OLTP perspective. And when you start to look at SQL Database, that gives you that ability to have elastic scale, both up and out. And that way you only have to pay for the resources that you need. So here's the way to think about it. When you have a database and you need to get additional resources, what do you really need to do to get those additional resources? How do you get more memory? How do you get more CPU? Well, with an on-premise database, you basically are stuck with, can I get a new server? That's one of the options. The other one is, can I get a new chip for my server? Now, I've heard people over the years talk about this and saying that, we're going to buy the lower grade chip today, and then tomorrow when the demand is there, then we're going to go through and then we're going to get a larger chip and we're going to upgrade our CPUs. That is all fine and dandy. In 17 years of working with SQL Server, I've never actually seen that happen. Every single time that people have asked for that additional CPU that they were promised at the beginning of the project, for some reason there still just isn't budget for that. And so you really don't have that ability to scale up. And even if you were able to get it, the point in which you need to scale up is right now. It's not in 6 weeks. And so if you move the database up to the cloud, you have that ability to scale up because you can move between those service levels. If I jump over to SQL Azure here, if I go back into my database, I can, within any one of these databases, open it up, go into my configuration, and, oops, where is it? Scale. There we go. Scale into any one of the options. And at that point, I can scale between the different sizes and decide how many DTUs I want. And so once I get to there, then I save it. It takes a couple minutes to push that change out there. It doesn't take a couple months. A couple minutes, way better story than a couple months. Now, there is a point, though, where you're going to scale outside of what you can get from a single database. And that's where some of the components and features within SQL Database and the development community around what people are already doing with SQL Database can really give you some additional opportunities. One of those is through sharding through a scale out. So you can scale up by changing which subscriptions you're using. The other option is for doing scale out architectures. Now, some people are out there using federations. Federations work fine and dandy, but what I look for when I'm working with doing any sort of scale outs is I want to be able to take discrete units and add them in without having to do any additional work from a data architecture perspective. I don't want to have to redistribute data. And when it comes to doing a scale-out process, you can do some dynamic work by doing something similar to sharding. And with sharding, what you end up having is a central node where as soon as you need to add out additional scale, you can add an additional database in, or maybe even a third database, or a fourth, or a fifth. And if you need to go back, you can pull one of those databases out and then add it back in when you need it. And what sharding does is it kind of partitions your workload into logical units of work that are spread out across multiple SQL database instances. It's a great way to being able to scale up and scale down your data warehouses. I mean, not your data warehouses. Sorry, I've got the PDW thing on there. That kind of confused me for a minute. But it's a way that you can really expand out your platform, and you're not confined within the one data center and the one database that you're currently locked into when you're doing on-premise databases. To be able to do sharding or partitioned views across multiple databases, it ends up being a lot of work. And some of these scale-up options are minutes to get it in place. And the scale-out option, if you build it into your architecture, you can have fully scalable applications that can scale from 10 to 1 million users with minimal effort on your end. And so that wraps up what I wanted to talk about for leveraging the cloud for the SQL developer today. If you have questions, please put them into the Q&A or send me an email and I will answer them. I believe we have 2 minutes left. Rachel can confirm that for me. So if we can go through a couple questions. But if you do have, if you want any resources, we do have some information on our cloud service offerings on the Pragmatic Works website. And if you just want a couple hours of time with myself or one of the Pragmatic Works team to talk about some of these things today, we do have a VM DBA offering where you can pay by the hour for a few for some consulting.
Yeah, exactly.
All right, questions?
I was just going to mention also, Jason, you mentioned earlier that Microsoft has renamed several other different platforms and systems, and you know, being in marketing, I know that they just redid that for PDW as well. They renamed it for APS, right? So it's now that analytic platform
it's analytics
system.
Platform system with PDW regions and Hadoop regions. Yeah, it's great.
Yeah. It's fun, and I don't think the actual appliance got renamed, so it's kind of a little bit confusing somewhat, but but it's kind of interesting that they do that.
Yes. Do we have time for a question at least?
You know what? Actually, I made you an organizer, so if you want to, I think you can view the questions panel. So if you want to pick one out that you want to address in the last minute we have.
Okay, so that actually showing up right on the screen, isn't it? All right. So I got a question here. Have I compared MS with Google and Amazon? From a feature perspective, I have not done that yet. From a cost perspective, I've done a little bit because I like watching their race to the bottom. Right now, this week, Microsoft is cheapest on pricing for cloud-based solutions, but that's probably not going to stay stay the same for too long, and then somebody else will be cheaper, and then somebody else will be cheaper. It's one of the great things about cloud-based solutions is that it is a race to the bottom, and soon this stuff will probably be almost free.
Awesome. All right.
Next question that I have, and I think that'll be the last one I'll be able to answer, is when you have to migrate from Cloud 2012 to Cloud 2014 to vNext. No, what ends up happening is there are, I want to say AUs, which is appliance updates, which is not the right term. They might be service updates. I can't remember the exact term that they use for Windows, for Microsoft Azure, but what they do is on a 6 to 9 month basis, they release new features into Azure. And so there's nothing that's really considered a SQL Server 2012 or SQL Server 2014 version of SQL Database. It is today's version of the features, and in a few months you'll have a very similar version of SQL Database that's out there and running, but you never end up having to jump between versions because it's a moving target, and moving target makes it sound bad, but it's an increasing feature set time over time. And actually, if you've been paying attention to the messaging from Microsoft, if you want the best and the newest features for SQL Database, you're going to find, and it's probably getting really quick to the point where this is going to happen, that new features will be in SQL Database years before they show up in your on-premise databases. Because, I mean, that's the place where most of the teams are moving over to. Most of the guys that I've talked to in the SQL teams, their first priority is SQL Database and the Microsoft Azure platform, and then looking at how they can bring that over to on-premise. And so I think that's all the question time that we have for today, because I think I'm technically over by a minute. So thank you, everyone, for coming today. If you have questions, please just send them over to me, and I will answer them in an email, and I'll re-answer the ones I've already answered here today.